My name is Dan Behrens, and I'm a technical marketing engineer with Cisco's IoT business unit focused on our industrial security solutions. In this video series, we're discussing the deployment of Cisco Cyber Vision. We're talking through some of the best practices, as well as how you can deploy it in your environment. In this video, we're going to focus on the deployment of the sensor to the Cisco Catalyst Industrial Ethernet 3400 ruggedized series switches. Bear in mind that while we're going to be showing the IE3400, these same commands and same information is still true for the IE3300 and the IE3300 10GB uplink models. Cisco Cyber Vision is often referred to as a two-tier architecture, with the first tier being the Cyber Vision Center. This is the main interface from a user perspective, and also where we have the ability to deploy the Cyber Vision Sensor software from, as you'll see following up in the video. For more information on deploying the center, please see video 1 of this series where we discuss deploying the center into a VMware ESXi environment. The other component is the Cyber Vision Sensor. This is the piece that actually performs deep packet inspection, actually understands or decodes industrial protocols, and it's sending that information to the center in the format of what we refer to as application flow, or essentially metadata. The benefit is that metadata makes up about 1 to 5% of the total traffic that the sensor is receiving. So you're not required to send all of the traffic from the environment back to some centralized location for the analysis of the environment to occur. Many devices in the Cisco portfolio have a functionality known as application hosting, or you may hear it referred to as IOX. This is the ability for these platforms to actually run applications leveraging the existing additional hardware and capabilities that the platform has. In this video, as discussed, we're going to dive into the IE3400. When deploying the sensor onto an IE3400, there are some prerequisites that we need to discuss. First of all, there's the operating system, or iOS XE, of the switch itself. It is recommended at the time of this recording to run version 17.6.5, but it needs to be a minimum of the 17.1 version to actually provide that IOX or application hosting functionality. The IE3400 does have an SD card that can be leveraged for backup and restoration of the switch itself. We're going to be leveraging that SD card for the actual storage of the sensor itself. And so we do need to have an SD card installed and formatted appropriately. And we'll talk through the steps here. Starting in 17.5, there was a new feature called partition that was introduced to the platform, which allows me to use that SD card for both the backup and restoration capabilities of the switch and for the storage of the Cyber Vision Sensor application itself. However, I can also just format the card in ext4, in which case the card would just be used by the Cyber Vision Sensor. And we'll talk through those steps as we go through the actual procedure. I do have to have the application hosting or IOX functionality enabled. And I need to make sure that the web access or the web UI for the switch itself has been configured to give me privilege 15 access. And the last piece is that the Cyber Vision Center does need to have the ability to reach the switch's management IP address as well. There are options when it comes to deploying the sensor on the IE3400. The first mechanism, and the one we're going to talk through in this video, is leveraging what's known as the Sensor Management Extension. This is actually giving functionality to the center itself to push the application to the switch. This is the preferred method as it makes upgrades and management over time a much easier process. There is also the ability to leverage an Ansible script to deploy the sensor, and we provided that up on our developer at cisco.com or through DevNet program. The benefit here is that I can deploy the sensor to multiple switches at a time. However, I do have to manage upgrades and the configuration of those sensors over time as well. There is also a manual mechanism, and this is discussed in the deployment guides, and this can be done through the web UI itself or through the command line interface. Again, the major downside to this method is that I have to manage upgrades and the configuration of the sensor over time manually on my own. So if I deploy manually, upgrades are done manually in the future as well. In terms of networking for the sensor itself, the idea here is essentially as traffic is flowing through the switch, we're going to leverage a monitor session to capture that traffic and send it to the sensor application. And so this is actually a copy of the traffic is being sent to the sensor to perform its DPI. When looking at the switch, there's actually a new interface, or App Gigabit Ethernet 1/1, which is a virtual interface that connects the switch itself to the application that's running inside IOX, or the application hosting framework. In the case of the sensor, this means that we're actually providing multiple interfaces to the sensor. ETH0, or the collection interface, is used for the communication from the sensor to the center. ETH1, or the capture interface, is the one we're actually sending traffic to. So this is actually the interface that's performing that deep packet inspection. And then if I'm leveraging active functionality on the sensor, I can add additional interfaces for the active functionality itself. So for today's deployment, we're just going to focus on the passive deployment, which is just going to leverage ETH0 or the collection interface and ETH1 or the capture interface. When leveraging application hosting or IOX, we're going to leverage the Linux bridge functionality to get the information from the switch itself into the virtual interfaces, or again, that ETH0 and ETH1 of the sensor. And the way the platform actually differentiates the communication for each interface is leveraging the .1q header. So we'll actually configure app gigabit Ethernet 1/1 as a trunk interface. As you know, trunks by default have a native VLAN of 1, and on the native VLAN we don't tag traffic. So it's important if you're going to look to leverage VLAN 1 for the ETH0 or the collection interface communication, again from the sensor to the center, that we change the native VLAN of that trunk interface to anything besides 1. The point being is that we need the traffic to actually have the VLAN .1q header for the Linux bridge to understand which interface to send it to. If you were to accidentally deploy or leveraging VLAN 1 and not changing that trunk native VLAN to VLAN 1, the sensor itself will actually not be able to communicate to the center, and you would see it in a disconnected state on the center. So that's one area that we often see miscommunication or misconfiguration occur, and wanted to make sure we call that out here. Now, as discussed, ETH0, the collection interface, is the sensor-to-center communication. And ultimately what that means is that ETH0 needs to have reachability all the way back to the collection interface on the center itself. Again, this is what allows that sensor to communicate to the center. ETH1, or the capture interface, is actually what's receiving the traffic. And as you'll see as we go through, it'll actually be the destination that we define for the monitor session. So we're going to assign an IP address to ETH1, or the capture interface, and that IP address needs to align with how we configure the monitor session on the switch itself. And we'll see that as we go through the example here today. The big piece here, though, is that capture interface is only significant to the switch itself. In other words, the monitor session needs to be able to send traffic to it, but it doesn't need to be reachable outside the switch itself. And it is important to call out that on the IE3400s and IE3300s, that we do not support the ability to actually send RSPAN or ERSPAN from external switches into the IE3400 or IE3300 itself. So this really is designed for capturing the traffic that is local to the switch or for end devices that are connecting directly to the switch itself. For the rest of the example, we'll be leveraging an architecture similar to this. We're going to have a IE3400 with a management IP address of 192.168.2.30, which is assigned to VLAN 2 on the switch. And then we're going to be deploying a sensor with a collection interface in VLAN 6 of 192.168.6.30, and we're going to be using the capture interface of 172.16.0.30 for VLAN 998. Connected to the switch, we do have some industrial devices. So on Gig 1, 7, 8, and 9, we do have a Rockwell controller as well as some Rockwell I/O and a Siemens PLC. And all of those devices are on VLAN 3. So here I've connected to the command line interface of the IE3400. First, let's go ahead and check the operating system version. And we can see it is running 17.11.1, which is above the minimum needed of 17.1. Next, we'll check for the SD card. And here we can see that the SD card is present, but is currently formatted as a VFAT type. For leveraging the SD card for IOX or for application hosting, the card does have to be formatted in the ext4 format. Now we have a couple of options here. The SD card in the IE3400 can really serve two purposes. One is to be the actual backup and restore functionality of the switch, so you can store the operating system and the configuration of the switch on the SD card. And in the event of a failure, you simply move the card over to the replacement switch and boot it up, and it will be leveraging the same operating system and the same configuration as it was previously. But it can also be leveraged as our storage for IOX or application hosting. The big difference is that we use VFAT for the backup and restore, and we use ext4 for the IOX functionality. So if I'm not leveraging the card for backup and restore and I just want to use it for my application hosting, I can simply format the card in ext4 with the command format. However, this is going to consume the entire card and just provide that card access for IOX itself. The other option is we can partition the card, essentially creating two separate storage spaces, one that can be used for the backup and restore, and one that can be used for application hosting. To do this, the command is the partition command. And here I will provide the percentage that would be used for IOX, and the remaining space is leveraged for the backup and restore functionality. Specifically for Cyber Vision, I would recommend leveraging the percentage of 72. And as you will note, you will receive a warning. Doing the partition command will require the switch to reboot. So I will go ahead and say confirm, and the card will be partitioned, and the switch will go ahead and reload. Once the switch is restarted, I can reconnect and verify the fact that the SD card is now partitioned. And we can see now that there are two partitions, one specifically for IOX leveraging ext4, and one for the backup and restore using VFAT. Next, we'll check on the actual status of the application hosting or IOX functionality. As expected, it's not currently running. By default, IOX is not enabled, so I simply need to give the command to enable IOX, which is the IOX command in the configuration mode. And once I've enabled IOX, there is a warning that comes up recommending not to remove the SD card once I've enabled IOX. After some time, I can then check the status of IOX with the show IOX command, and I can see now that the services are all running and I'm ready to move forward. Next, I need to make sure that the switch is using authentication for the web access or the HTTP access, and I can do that with a simple show run. And as expected by default, the HTTP authentication has not been defined. So I can simply do that through the configuration mode, and the command is IP HTTP authentication. And I can see here that I have the ability to leverage AAA, the enable passwords, or my local username and passwords that have been defined. In my setup here, I am using the local, but you'll set this configured based on how you are authenticating other actions on the switch. Next, I need to prepare the switch for hosting the sensor itself. As discussed, the app gigabit Ethernet 1/1 interface is the communication or the interface that connects between the switch and the application itself. So we'll look at the default configuration of that interface. And we can see, like other interfaces on the switch, there is no configuration applied initially. So we'll go to the configuration mode and configure that interface as a trunk. And now we can see the port has been configured as a trunk. And now if I do a show interface trunk, I can see that app gigabit Ethernet 1/1 and my uplink into the rest of the network in my environment, or gig 11, are both configured as trunks. Next, to prepare the switch for actually capturing traffic and sending it to the sensor, first I'll configure a remote span VLAN. Again, in my environment, we're going to leverage 998, so I'll go ahead and configure that VLAN and define it as a remote span VLAN. You can also name the VLAN, although it's not required. Next, we're going to configure the monitor session to capture traffic and send it to the sensor itself. So first of all, we'll configure the source. Again, in my environment, the end devices are directly connected on VLAN 3, so I'll use VLAN 3 as the source for my traffic capture. And then we're going to send it to the remote VLAN, in my case 998. And what you'll notice is I've received an error. Now, I've done this on purpose just to illustrate it for you, but one of the things about the IE3400 is that I am limited to sending the RSPAN VLAN to a single interface. Whenever you create a brand new VLAN, if you're not explicitly removing it from all of the trunks on the switch, it will automatically be allowed on those trunks. So if you go ahead and do a show in trunk again, we can see that 998 is allowed both on the app gig 11 and on the gigabit Ethernet 1/1 interface. The way to fix this is to remove it or to not allow it on gigabit Ethernet 1/1. And we'll do this with the switchport trunk allowed VLAN command. In my environment, I'm going to explicitly remove 998. The inverse is to only allow specific VLANs. And now we can see that I am allowed to give the destination of remote VLAN 998 because it's only allowed on the trunk interface or the app gig interface between the sensor and the switch itself. And the last piece is that we're leveraging an ER-SPAN style header, and so we'll give the command for it to explicitly send the traffic to the sensor itself. Note that after the format ER-SPAN, I do have to give the destination IP address, which again in my environment is going to be the 172.16.0.30. That will apply to the capture interface of the sensor itself in future steps. So it's important for these values to match, as you'll see as we move forward. So to recap, what we've done is we've partitioned the SD card to be available for application hosting. We've then enabled application hosting with the IOX command. We configured the HTTP access to be authenticated with our local user. We've configured the AppGig interface to be a trunk. We've created a remote span VLAN and made sure that it is not allowed on any other interfaces besides the AppGig 11. We've configured the monitor session to capture traffic from the VLAN that my end devices are connected, in my case VLAN 3, and we're sending it to the capture interface that we will configure in the sensor in the next step. Next, we'll move into the Cyber Vision Center, where we'll leverage the sensor management extension to push the application to the switch. The first step will be to download the Cyber Vision Sensor Management extension from Cisco.com. So if I navigate to the Cyber Vision downloads and go to the center, you'll see that for each release there is the Cisco Cyber Vision Sensor Management extension for IOX that will be related to the version of the center that you're running. You do want to try to match these versions with each other. So as of today, the latest version is CyberVision 4.2.3, and so I'll be downloading the CyberVision 4.2.3 Sensor Management Extension, which is a .ext file. Once you've downloaded the ext from Cisco.com, we then can navigate to the center itself and go to the admin section. And under the admin menu, you'll notice the extensions menu. We'll simply provide the extension file, which will upload the file to the system and prepare the sensor management extension to be leveraged. And once the Cyber Vision Sensor Management extension has finished uploading, I will be greeted with a successful message letting me know that it is finished. I then have the ability to navigate to the sensor area and go to the Sensor Explorer. And under Install Sensor, I'll now see I have the ability to access the Install via Extension option. When installing via the extension, I'll first provide the IP address of the switch. And again, this is that 192.168.2.30 address, as well as the port that will be leveraged. On the IE3400, this will be port 443. And I also have the ability to define the center collection IP. By default, the system will automatically use the IP address that's been assigned to the collection IP interface of the center. However, if there is an environment where you're leveraging network address translation or other more dynamic routing functionalities, I can provide this address if it is different from the address the center knows to use for the collection interface. In my environment, because it's just a simple route, I am going to leave this blank. I also have the ability to provide the credentials to connect to the switch. I can leverage global credentials, which means the system will use those same credentials for every switch that I'm connecting to, or for each individual switch, I can use custom credentials. And last, I can define the capture mode. This is going to identify what level of DPI is being performed at the sensor level. Essentially, by default, the sensor is going to do an optimal configuration, which means that it's going to analyze the majority of the traffic, with the exception of some multicast and some broadcast and some additional traffic that realistically doesn't provide a great deal of value. We can also analyze all of the traffic, so that means that there will be no filtering that will be occurring, and the sensor will analyze all the traffic that it receives. We can choose industrial only, which means it'll be more focused on identifying and observing industrial traffic and ignoring traffic like web requests and HTTP details and things of that nature. Or last, I do have the ability to define a custom filter. In this case, we're actually leveraging a TCP dump style filter, where essentially I can pick and choose exactly what traffic I want to analyze. I could eliminate specific hosts, or I could focus on specific hosts or specific types of traffic and things of that nature. Again, this really allows me full customization in terms of how the filtering will occur. And this is what we're defining, essentially what traffic is going to be analyzed by the sensor itself. The recommendation would be to leverage the optimal by default. Once I've provided all those details, I'll click Connect. And the system is going to reach out and connect to the switch. Now, again, because we've done things like enable the HTTP authentication, we've made sure IOX is running and all of those different functions that we've performed on the switch, it does successfully connect. And I do see that the system comes back. It does tell me the model of the switch that's connecting to, which kind of gives me a validation that that is happening. And here's where I can actually define the configuration of the sensor itself. So for the capture IP address, this is the address that I'm sending traffic to. And so as we've discussed, I'm going to be setting this at the 172 network. The prefix length, or the subnet mask, in this case we will leave it at the default of 30. And the capture VLAN, again in my configuration I am leveraging VLAN 998. Now the collection IP address is again the address that I'm assigning to the interface of the sensor that's going to be used to communicate back to the center. In this case, in my environment, I am leveraging the 6.30 address. The prefix length of the subnet mask in my environment is a 255.255.255.0 or /24, as well as I can provide the default gateway that the sensor can leverage for routing. In my environment, it is the .1 address. And last, I can define the VLAN that will actually be assigned to the interface. Again, in my environment, that is the VLAN 6. Once I've provided all those details, I can click Next. I'm then greeted with the option for how I want to deploy the sensor. Again, I can choose a passive only, meaning it will only receive traffic and analyze the traffic that it is receiving. Or I can choose it for the sensor to be both passive and active. And in this case, active means actually leveraging industrial protocols to generate traffic or communications in the environment to identify devices. For this video, we're just going to focus on the passive, and I can click on Deploy. And once that process has begun, I then can go to the Jobs page to monitor the status of the deployment. Now what's occurring behind the scenes is the Cyber Vision Sensor Management extension is pushing the application to the switch. It's then starting the application, and once it's started up, it's then providing that configuration to the application. So it will take a few moments for this to fully process. And once the sensor has finished being deployed, I will see the 3 check marks indicating such. And now I can move back to the Sensor Explorer. And we can see that the sensor has in fact been deployed. It currently has a status of connected, and it is processing the data that is being received via the DPI. And with that, we've deployed the sensor to the IE3400. Stay tuned as we discuss how to analyze the data that the system is receiving, how to optimize that information, and leverage it inside your environment. Hopefully this was informative. Thank you, and have a great day.